Welcome back to Pre-Algebra with Miss Betsy. In this lecture we're going to set up 2 or 3 equations from word problems, and we're going to go ahead and solve those. Before we do that, I'll remind you that I'm using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press. I am using the first edition. We're on page 257 of our text, section 8.3, problem solving, writing equations. If you're not using this text, you can still gain some knowledge from watching the video anyway. Now, if you would hang on, I'll look and see what my lamest joke is for today. And this says, what has a foot on each side and one in the middle? That, my friends, would be a yardstick. So, I've gone ahead and written 4 sentences on the board. You'll find these in your text, but this is just sort of guidelines that you can use if you want to write an equation to solve a word problem. What's the first thing you have to do if you're solving a word problem? That means there's something out there that you don't know what the value is, and you're trying to find that. And in algebra, that's what we call an unknown. Something that you don't know what it is an unknown, and we're going to pick a variable to represent that. You might just pick a generic variable, like just say let x be whatever it is that you're looking for. Or perhaps if you're looking for the number of dogs, you might say let d equal the number of dogs, or let n represent the number that we're trying to arrive at. But we're going to pick a variable to represent an unknown. It makes no difference whatsoever at all what variable you select. Then we're going to read a little bit further in our problem, and we're going to make certain that any other conditions that we find in that problem, that we represent those conditions in terms of the same variable that we've picked up here in the front. Like if we're talking about Bill's age, and we say let's have B represent Bill's age, and we say that John's age is 2 more than Bill's age. Well, we're not going to use a J for John's age. We're going to say B for Bill's age plus 2 to be the value, or to be the expression that we use to represent John's age. So we've got all of our conditions represented using our variable that we have selected. Now we have to figure out what 2 quantities are equal in your problem, because you've learned that an equation is like a balanced seesaw or a balanced scale, where everything on the right-hand side of the equation is equal to everything on the left-hand side of the equation, and it's in balance. So you have to identify what 2 quantities are equal, and then once you've figured out what is equal, then you can go ahead and write and solve an equation. Let's go ahead and look at example on page 257. This says write an equation and solve. Tony bought a new trumpet for $298. He made a down payment of $46 and arranged to make payments of $28 per month. How many months did it take for him to pay for the trumpet? Now, if you just look at that whole big mass of words there, your brain's going to go tilt, tilt, tilt. And you're going to be overloaded, and it will be difficult for you to arrive at the solution. So let's make sure that we don't hyperventilate when you read a paragraph-long sentence. And let's just go back and look at it and see what we're actually looking for. What do we want to do? Well, first we want to represent an unknown with a variable. So what are they asking for? Got a new trumpet, a down payment. How many months did it take for him to pay for the trumpet? So that's what we're looking for. We are looking for the number of months. So, in this case, why don't we just say, let M equal the number of months to pay for the trumpet. Okay, That's really the hardest part sometimes, is finding out exactly what it is that we're trying to identify. Here we want to know how many months it took Tony to pay for his trumpet. So now let's see what we have. Tony bought a new trumpet for $298. He made a down payment of $46. So what does it mean when you make a down payment for something? Well, when you make a down payment for something, you have paid a part of the total cost of your purchase. For example, if you're going to buy a car for $20,000, which I hope you don't, I hope you pay cash and spend far less than $20,000 for a car. But let's say that you're going to buy a car for $20,000 and you make a down payment of $2,000. What you've done is you said, okay, here's $2,000 towards the $20,000 that I owe you. So how much do you now owe the person? Well, you owe the person or the dealer $20,000 less the $2,000 that you paid, or you owe $20,000. Okay, so we see that we have a total price for the trumpet of $298, but that's not how much Tony still owes, because he has paid $46. Now, he arranged to make payments of $28 a month to pay for the trumpet. So how much is he going to pay each month for the trumpet? He's going to pay $28. So we could say that 28 times M is the amount per month that he's going to pay, or $28 rather. $28 is how much per month he's paying. And then we're going to say we're going to pay $28 per month. Because what we want to do is come up with, okay, we have to take the amount of money that he's going to pay every month until it's paid, and have that be either equal to how much he owes or equal to the total cost for that trumpet. So what we have now is that M is the number of months that he's going to pay, 28M. 28 times M is the amount of money that he's going to pay until he pays off this vehicle. So until he pays off this trumpet. So let's see what we want to do for our third step. Third step, we have to see what do we have as equal. Well, we know that $298 is the total cost of the trumpet. And we know that $46 is the amount of the down payment. And we also know that he is going to pay, for some unknown number of months, $28 a month. So let's see, how could we set this equation up? Well, we could say his monthly payment, the total of his monthly payments, plus the down payment, is equal to the total cost of the trumpet, couldn't you? So what's the amount of his monthly payments? It's 28M. What's his down payment? $46 is equal to the total cost of the trumpet, $298. There is another way that you can look at this. This is the expression that they come up with in your equation, so I'm going to go ahead and key in on this. But let's think about it a different way. Couldn't we say that, how much money does he already have to pay? Well, he's paid $298. He has to pay $298, but he's already paid $46. So the total amount of his monthly payments, 28M, is going to be equal to the initial total cost of the trumpet minus the amount of the down payment that he's already made. Both of these represent the same quantity. Here we have monthly payment plus down payment is total payment. Here we have monthly payments remaining, or balance remaining, is paid monthly, is the original cost reduced by the down payment. And you can already see that when we solve this equation here, the first step is going to immediately bring us down here. Let me go ahead and erase this and I'll show you what I'm talking about. So if I have 28m plus 46, 28m plus 46 is equal to 298. What am I going to do here? We want to isolate that variable. So we have to see, okay, we've added 46 to 28 times the variable, so we have to subtract 46 from both sides of the equation. 298 minus 46. And see, we're right at this point already. Now we end up with 28m is equal to 298 minus 46, which gives us a difference of 252. Do I care what 28m is? No, not in the least. I care what 1m is. I've multiplied by 28, so I'm going to divide both sides of my equation by 28. 6, 7, 8, 9. Okay, I know it's not 10 times 28. I think it's probably going to be 9 because 8 times 9 is 72. But I still really don't want you using your calculators. So let's just go ahead and divide 252 by 28 and try a 9. 8 9s are 72, carry 7, 18 and 7. Oh, weird. See, don't like to do long division. Didn't have my places set up properly. Put the 9 in here because you can't count 28 out of 25, can you? 9 times 8 is 72. We're going to carry 7. 9 times 2 is 18, plus 7 is 252. So we have m is equal to 9. Well, 9 what? 9 puppies? $9? Well, it's 9 months to pay for the trumpet. And this is what you're going to need to do. You analyze your statement. We found our unknown, which was the number of months. We were talking about $28 per month. So the monthly payment we expressed in terms of this variable m. We included our down payment, and we used the properties of inverse operations to solve our problem and end up with 9 months to pay for the trumpet. How would we check this problem? We would take 9, substitute it back into the original equation, and make certain that we ended up with 298 is equal to 298. That's all we have for today. Work hard on these problems. I know you can do them. I'll see you next time.